Welcome to Astronomy Daily, the podcast that brings you the latest news from across the cosmos. As we like to say, give us 10 minutes and we'll give you the universe. I'm Avery.
And I'm Anna. It's great to have you with us. We've got a packed show for you again today, covering everything from historic launch pads being retired to incredible new discoveries by the James Webb Space Telescope.
That's right, Anna. We'll be looking at China's progress on reusable rockets, Australia's orbital ambitions, and we'll end the show with a deep dive into some of the biggest unsolved mysteries in space.
So let's get started. Avery, first up is an end of an era for SpaceX.
It certainly is. SpaceX is decommissioning its original Starship launch pad, known as Pad 1 or suborbital Pad A, at its Starbase facility in Texas. This pad was the workhorse for the early days of Starship development, seeing a total of 11 flights.
It's amazing to think about the history made there. This wasn't just a simple concrete slab. It went through some massive upgrades over the years.
Absolutely. It was eventually equipped with a full launch tower, a water deluge system to protect the pad from the intense heat of liftoff, and even the arms designed to catch and support the massive super heavy boosters for reuse.
A true testament to their iterative design process. While it's sad to see it go, I imagine they need the space for the next phase of development.
Exactly. They're moving on to bigger and better things with their new orbital launch site. But Pad 1 will always be remembered as where Starship learned to fly.
Speaking of reusable rockets, SpaceX is getting some serious competition from China. The Chinese company Landspace has been making some impressive strides.
They have. They're developing the Zhuque 3 rocket, which looks remarkably similar to Starship. It's a stainless steel, methane-fueled, reusable launch vehicle, and they just hit a major milestone.
The static fire test, right? That's a crucial step.
Right. They successfully completed a static fire test of the first stage prototype. This is where they fire up the engines while the rocket is securely bolted to the ground, testing the entire system under flight-like conditions.
So what's next for them?
Landspace is aiming for its first orbital flight test in late 2025. This is all part of a much larger ambition for China, which is heavily investing in building its own space infrastructure, including a satellite constellation similar to Starlink. The pace of their development is really something to watch.
From engineering marvels on Earth to incredible discoveries far from home, the James Webb Space Telescope has done it again, this time giving us a peek into how moons might be born.
This story is fascinating. Webb has observed a disk of material swirling around an exoplanet about 600 light years away.
And this isn't just any disk. It's what's known as a circumplanetary disk, and it's the first time we've seen one that is rich in carbon. Scientists believe these disks are the birthplaces of moons, or exomoons in this case.
So we're essentially watching a moon system in the process of forming, much like how the moons of Jupiter or Saturn might have formed in our own solar system billions of years ago.
Precisely. The finding provides a rare, real-time look at the building blocks of moons and helps us understand the conditions under which they form. The power of the Webb telescope continues to unlock secrets of planetary formation that were completely out of reach just a few years ago.
Let's bring our focus back to Earth now, specifically to Australia. The Australian rocket company Gilmour Space is gearing up for another shot at reaching orbit.
Their first attempt didn't quite make it, did it?
Unfortunately not. The flight was terminated shortly after liftoff due to an anomaly. But in the world of spaceflight, failure is often part of the process. The company has analyzed the data and is now targeting 2026 for its second orbital attempt.
It's a resilient industry. What does this mean for Australia's space program?
It's a huge deal. A successful launch would make Australia the 12th country to reach orbit from its own soil. Gilmour Space remains optimistic, and their determination is really fueling the growth of the nation's sovereign space industry. We'll be watching closely in 2026.
All right. For our final segment, let's venture into the unknown. Despite all our incredible technology and discoveries, Space is still filled with profound mysteries that continue to puzzle scientists.
My favorite kind of topic. Where do we start?
Let's start with the big one, the Hubble tension. For years, there's been a major disagreement on just how fast the universe is expanding. Measurements from the early universe, like the cosmic microwave background, give us one number. But measurements from the local modern universe, using things like supernovae, give us a different number, faster.
And the fact that they don't match suggests we might be missing something fundamental about the physics of the cosmos.
Exactly. Next up, fast radio bursts, or FRBs. These are incredibly powerful, millisecond-long bursts of radio waves from deep space. We know they come from distant galaxies, but we have no idea what causes them. Theories range from magnetars to alien signals, but nothing fits all the data.
A true cosmic whodunit.
Then there's the giant elephant in the room, dark matter. We see its gravitational effects everywhere, in the rotation of galaxies, in the bending of starlight, but we can't see the stuff itself. It makes up about 85% of the matter in the universe, and we have no idea what it is.
It's humbling to think that we've only ever observed a tiny fraction of what's actually out there.
It really is. Let's touch on a few more strange ones. We recently detected the second longest gamma ray burst ever seen. It lasted for over 1,000 seconds. We think these bursts come from collapsing massive stars, but one lasting that long challenges our models. Wow. Then there's Hoag's object, a bizarre galaxy that looks like a perfect ring of young blue stars surrounding an older yellow nucleus with almost nothing in between. We don't know how it formed.
That sounds like something out of science fiction.
And another great mystery, closer to home, the hunt for Planet 9. The strange clustered orbits of several objects in the outer solar system suggest there might be a massive, undiscovered planet lurking out there, 10 times the mass of Earth. But despite years of searching, we haven't found it.
These mysteries are what make astronomy so exciting. For every answer we find, we uncover 10 new questions. The list of cosmic conundrums is seemingly endless. Take the Great Attractor, for instance. It's a massive gravitational anomaly located in the direction of the Hydra Centaurus supercluster, pulling our Milky Way and countless other galaxies towards it at incredible speeds. The problem is we can't observe it directly because it's hidden behind the zone of avoidance, the dusty, star-filled plain of our own galaxy.
It's a mind-boggling concept, like a hidden cosmic behemoth shaping the structure of our local universe. And speaking of strange observations, we have to talk about Tabby's star, also known as KIC 8462852. This star exhibits bizarre and extreme dips in its brightness. We're not talking about the tiny, regular dimming of a transiting exoplanet. These are massive, irregular drops, at one point blocking over 20% of the starlight.
That's the star that famously led to speculation about alien megastructures, like a Dyson swarm. While that's an exciting thought, the more plausible, though still unconfirmed, explanation is a vast, uneven ring of cosmic dust orbiting the star. But the irregular nature of the dimming events makes it a persistent and unique puzzle that defies easy explanation.
It's a perfect example of how one strange object can challenge our assumptions. Then there's the other side of the dark coin, dark energy. We discussed dark matter, the invisible glue holding galaxies together. Dark energy is its antithesis, a mysterious, repulsive force causing the expansion of the universe to accelerate. It's believed to account for nearly 70% of the universe's total energy density, and we have almost no idea what it is.
So, to recap, about 25% of the universe is dark matter, which we can't see, and about 70% is dark energy, which we can't explain. That means all the stars, planets, and galaxies, everything we've ever observed, make up less than 5% of the cosmos. It's an incredibly humbling realization and drives home how much is left to discover.
Absolutely. And perhaps the most profound mystery is one that strikes at the heart of physics itself, the black hole information paradox. General relativity suggests that information that falls into a black hole is gone forever, completely erased from the universe. However, a fundamental law of quantum mechanics states that information can never truly be destroyed.
This creates a fundamental conflict between our two best theories describing the universe. To solve it, physicists may need a unified theory of quantum gravity, one that can explain both the macroscopic world of gravity and the microscopic world of quantum particles. Finding that solution could represent the single greatest leap in our understanding of reality.
It's incredible. These puzzles, from cosmic structures to fundamental paradoxes, are the driving force behind modern astronomy. They ensure that for every discovery we make, an even more fascinating question is waiting just beyond the horizon. And that's a perfect note to end on. It's a reminder of just how much there is still to explore.
That's all the time we have for today's Astronomy Daily. We hope you enjoyed our journey through the latest in space news and cosmic mysteries. Join us next time as we continue to explore the universe. I'm Avery.
And I'm Anna. Until then, keep looking up.